మీరు షేర్ చేద్దురు కానీ సార్.
ఓకే సార్, తప్పకుండా. ఓకే సార్.
Good morning to all of you. Welcome to the online YouTube classes. Now, already we have finished the 10th topic, that is the mensuration. Now, we are moving into the next topic, probability. One more eminent and experienced teacher, Purushottam sir, who is working in ZPHS Aropalli, Suryapet district. So now he is going to introduce the probability topic, who has already taught in our 10th class Telugu medium section and has a vast experience about more than 18 years in teaching profession, and the best resource person in the district also. He is awarded by best resource person. We are very pleasure to have such a great teacher to teach our online live streaming classes in DCEB Suryapeta. Purushottam sir, please go through the concept.
Okay sir, thank you. Thank you very much. Good morning. Good morning to all of you. Today, we are going to discuss 10th class English medium topic, that is probability. So, probability is one of the most important and easy unit in 10th class English medium. So children, you are concentrate on this chapter. You may got good score in annual examination. So already we discussed about the definition of probability and some problems in our previous 9th class. On that basis, now we should learn about total, what is probability, and how can we solve the problems easily. So we remember the probability definition, children. So please remember the definition of probability. Already we have learnt in 9th class. See here, the probability theory is nothing but common sense reduced to calculation. So children, the probability means the common sense. Common sense means estimation, imagination, some calculation that reduced to numerically. So that definition was given by Pierre-Simon Laplace. Pierre-Simon Laplace, one of the mathematician. So once again, we give the definition of probability. Probability theory is nothing but common sense reduced to calculation. In our daily life, so many situations we imagine, we guess some matters. So those are reduced to calculation. Those are reduced to calculation. This is the best definition given by Pierre-Simon Laplace. So here, Pierre-Simon Laplace, one of the greatest mathematician related to probability. So here, children, here is a conversation is there. Please listen carefully. Kumar and Sudha were walking together to play a carom match. Both Kumar and Sudha were walking together to play carom match. The conversation. Kumar, like, do you think we will win the match? Kumar said, do you think we will win the match? We will win the match. So then Sudha said, there are 50% chances of that we may win. Sudha said that 50% chances. Kumar asked, do you think we will win? Sudha said, there are 50% of chance we may win, she said. So here, Kumar, how do you say 50%? Tell me, how do you say 50%? So, this is a, do you think Sudha is right in her statement? This is imagination. In this caroms, they may win or lose. But Sudha said, imagine, chances, 50% chances is there. So, this type of the caroms matches, win or lose, whatever it may be, but she said, she expected, we will win, 50% chance is there, we will win the match. So, that type of words here, is her chances of winning 50%? Really? 50% chance is there? So, these type of words like probably, likely, possibly, and how to quantify these. So, probably, some words are there. Already we discussed in 9th class. Equally, likely, impossible. There are so many words are there. Probably, likely, possibly. So, these type of words, we can quantify, we calculate, we change into numeric. Likely, that these type of words can change into numeric or quantify. How to quantify these? So, this is related to probability. Using probability, we are changing to numeric. These words are changed into numeric. That is probability, related to probability. So, listen children, this quantification into a numerical measure is referred to as a probability. These words, type of these words are quantification, calculation, change into numeric. So this quantification into numerical measurement, do you know measurements? So change into numerical is referred to as probability. So this is the definition. This quantification and these words are quantified is probability. So this quantification into a numerical measure is referred to as probability. Listen carefully, children. Write down in your notes is a probability definition. Or so some other definition is there. Probability is the mathematical measurement of uncertainty, certainty. Okay, children, write down the definition. Probability is the mathematical measurement. Is one of the mathematical measurement. Mathematical measurement of uncertainty. Already we learned about some words: probably, likely, possibly, equally likely, certain. Already in 9th class, we gave some more examples. Already we gave some more examples. So probability is the mathematical measurement of uncertainty, imagination, getting chances. So this is the definition of the probability. Please remember. children. So next week goes to, so here children, some other words are there like certain. The word certain, something that must occur. Certain means something that must occur. Certainty. For example, Mahatma Gandhi's Jayanti. Which day? Okay, that is October 2nd. So it is, so that is a certain. That is a certain. Some example. And more likely, something that would occur with a great chance. So it would possible with a great chance. The first one is certain. These words are related to probability. In children, certain, more likely, something that would occur with great chance, something that would occur great chance. And then next word, equally likely, something that have the same chance of occurring, equal likely. Already we learned equal likely. For example, when we toss the coin, when we toss the coin, so it would head or tail. So equally likely, like that. Equally likely. The caroms also one win, another loss. So they are equally likely. And here another word, less likely. Less likely. Something that would occur with a less chance. The chance is less. The chance is less. So these type of words, less likely, equally likely, certain, these words are related to probability. These words can quantify or we measure in probability. So another word is there, impossible. Another word is there, impossible. Something that cannot happen. Something that cannot happen. In our daily life, we may imagine. So it does not happen. It does not happen. It never will happen. So that type of situation. As impossible. We can say it is impossible. We can say it is impossible. So here these words are measured, like these words are measured. So in probability. So here toss the coin, roll the die. For example, in this picture is a toss the coin. Toss the coin. So toss the coin like this. Toss the coin used in so many games can start before we use toss. Before we use toss. So the toss is equally likely. So this is the die. It is the die. This is also cube. Die has 6 surfaces with a square. With a square, and also every surface has numbering 1, 2, 3, 4, 5, 6 or dots 1, 2, 3 like this. So this is a toss coin and this is a roll the die, because using these we can solve so many problems. First of all, we understood about toss and also die and also spinner also. In some daily life, we in our exhibitions, we see spinners. See, spinner is one of the game. So next, here children, we detailed definition. We try to give different definition about the probability. What is probability? Listen carefully, children. What is probability. Consider an experiment. So here, a normal coin was tossed 1,000 times. Head turned up 455 times, and the tail turned up 545 times. If we try to find the likelihood of getting heads, we may say it is 455 out of 1000, or 455 by 1000 or 0.455. So here I will give the definition once again. Trial or experiment, random experiment. Trial or random experiment. If we toss the coin, children, if we toss the coin, that is the one of the trial. Or if we roll the die, that is also trial or experiment, random experiment. Or we spin the spinner, that's a trial. That is a trial or experiment. So what is a trial? When we toss the coin, is one of the experiment. If we roll the die, that's the experiment. That is the experiment. Here, a normal coin, 1 rupee to 1 rupee, 5 rupee, or whatever it may be, 1 rupee, 2 rupee, any coin. So a normal coin was tossed, head turned up 455 times. How many times? Get head 455 times. And a tail turned up 545 times. Have understood? 545 times. If we try to find the likelihood of getting heads. For example, if we toss the coin, we may get head or tail. But only 2 outcomes are there. How many outcomes are there? When we toss the coin, how many outcomes are there? 2 outcomes. What they are? Head and tail. Another one. If we roll the die, die nothing but a cube. If we roll the die, how many outcomes are there? If we roll the die, how many surfaces? 6 surfaces. So 6 outcomes are there. If we roll the die, the outcomes we called as it outcomes. If we roll the die, 6 outcomes are there. What are they? 1, 2, 3, 4, 5, 6. So if we roll the die on the top, we may get 1, 2, 3, 4, 5, 6. 6. So here that's the outcomes. Here outcomes also. A normal coin was tossed. How many times here? 1000 times. We may toss one time. It may be head or tail. So here 1000 times. We toss here 1000 times. So head turned up 455 times. Head turned 455 times. And tail turned 555 times. If we try to find the likelihood of getting head, if we toss 1000 times, getting head means here 455 out of 1000. So here 455 by 1000. Here decimal 0.455. Next here. So here, and then this estimation of probability is based on the result of an actual experiment of tossing a coin 1000 times. So estimation. We may toss the coin 1,000 times. This is the estimation. So these estimation are called experimental or empirical probability. So here the definition is there. When we toss the coin or we experiment the experiment, or we toss the coin or roll the die. So these estimations are called experimental or empirical probability. Directly, we do that practically. We toss the coin, we roll the die, we spin the. This we do directly. So this type of probability is called experimental probability. Write down, children. This type of probability is called experimental or empirical probability. In fact, all experimental probabilities are based on the result of actual experiment. So here, and what is there? Experimental probability are based on the real experiments. Real experiment. They do the experiment. So and an aggregate recording of what happens in each of the events. They gather the information. With reality. They gather information with reality. Recording of the what happens in each event. They toss in some more situations. So they gather the information. They gather the information with the reality. So that is the experimental or empirical probability. These probabilities are only estimation. If we perform the same experiment for another 1,000 times, we may get slightly different data, giving different probability estimate. So one person can toss 1,000 times. He get 455 heads. Another person toss a coin how many times? 1,000 times. He get 500. So a slightly difference is there. So about gather that information. We estimate. These are the probabilities are only estimations. Already we learned these probabilities are only estimations. So if we perform the same experiment also 1,000 times, different probability is there. As a person. So here, next, here many persons from different parts of the world have done this kind of experiment and recorded the number of heads that turned up. So here, isn't here many persons. So throughout the world, different parts of the world, some mathematicians experimented and recorded their head that turned up and recorded their experiment results. For example, here the 18th century French naturalist Comte de Buffon tossed a coin 4,040 times and get 2,048 times head. Listen carefully, children. 18th century French naturalist Comte de Buffon tossed the coin. We may toss the coin. But here the French naturalist Comte de Buffon tossed a coin. How many times, children? 4,040 times. And get how many heads? 2,048 times heads. You get 2,048 heads. So the experimental probability of getting a head here, experimental. Notice this point. The experimental probability or empirical probability. Have you understood the experimental probability? So experimental probability, we directly do the experiment. So experimental probability, and we may imagine some, we may imagine the result and gather the information. So the experimental probability of getting ahead in this case was 2048 by 4040. That is here 18th century French naturalist Comte of Buffon tossed 4040 times. He tossed 4040 times and get 2048 heads. 2040 times head. So here the getting the probability, experimental probability of getting a head is what here 2048 by 4040. So that is 0.507. Here the probability is 0.507. So here toss here 4040 times. Next, and another mathematician J.E. Kerridge from Britain recorded 5067 heads in 10,000 toss of a time. So he tossed how many times? 10,000 times. How many times, children? 10,000 times. The getting head here recorded 5067 heads. 5067 heads. And the experimental probability, yes, what is the experimental probability of getting head is in this case was 5067 by 10,000. That is equal to 0.5067. 0.50. Someone 4040 times and some 5000 times. And here one of the mathematician J.E. Kerridge, he tossed 10,000 times. He tossed a coin. How many times, children? 10,000. And getting head is 5067 times. So the probability, the experimental probability of getting head, the experimental probability getting head in this case is what? 0.5067. So another statistician, Carl Pearson, spent some more time making 24,000 tosses. Here, 24,000 tosses at a time. He tossed 24,000 and he got 12,012 times head. 12,012 times head. And thus, the experimental probability of a head obtained by him was 0.5005. So, throughout the world, so many mathematicians can toss the coin in different ways. They gather the information. Here, Carl Pearson tossed the coin 24,000 times. Children, listen here. How many times? 24,000 times. How many times? 24,000 times. So he got 12,012 times head and remaining test. And thus the experimental probability is what here? 12,012 by 24,000. 12,012 by 24,000. 24,000. So the probability is 0.5005. Here also 0.5067. And previous example we got 0.405 like that. So here the probability is related like this. See this here 0.5067, 0.5005. And now here experimental or empirical probability. We learn full detail about experimental or empirical probability. Once again, children. So the definition is what here? The probability estimated on the basis of results of an actual experiment is called. Write down, children. Write down, children. The probability estimated. We can estimate. We imagine. Okay. The probability estimated on the basis of results. On the basis of result, they do directly. So here like this. Already we seen previous. Someone tossed 4,000, someone tossed 5,000, someone tossed 10,000, someone mathematician tossed 24,000. So that is experimentally, practically. So the probability estimated on the basis of results, of an actual experiment is called. Write down, children. The probability estimated on the basis of results of an actual experiment is called experimental or empirical probability. Write down, children, this definition. The probability estimated on the basis of results of an actual experiment. They do actually. So that type of probability is called experimental or empirical probability. So experimental probability or empirical probability. So another one. Next we go to probability a theoretical approach. So we listen what is the theoretical approach of a probability. So listen carefully, children. Let us consider the following situations. Suppose a fair coin is tossed at random. A fair coin is tossed. Already we may do that one. Suppose a fair coin is tossed at randomly. Watch here. When we speak of a coin, we assume it to be a fair. Fair means it contains head and tail. Both heads, not both heads, not both tails. It must contain a coin, must contain head and tail. Head and tail. That's the fair. That is the fair. So we assume it to be fair, that it is symmetrical, so that there is no reason for it to come down more often on the side than the other. So we call this property of the coin as being unbiased. Unbiased. By the phrase random toss. Random toss, we mean that the coin is allowed to fall freely without any bias or interference. Listen, children, here we toss the coin. The coin must be fair. The coin must be fair. So it has also unbiased. Random toss. So we toss freely. We toss freely. We don't force on that. So that is fall freely here. Here we mean that the coin is allowed to fall freely. So that is random toss and it is unbiased. We do not interfere. We do not interfere that kind. So the situation is there. The situation must be there. Then only fair, random toss, unbiased. Have understood? If we toss the coin, it must be fair. And also the random toss. And it fall freely on the ground. Then only that type of experiment we okay here random toss. Random toss. This is unbiased also. So we don't interrupt. We don't interrupt the situation other the coin also. Okay. So here children, these type of experiment are random experiment. Random experiment means it is a fairly unbiased and falling freely. So we do not force on that. Then only it gives equal likely outcomes. So these are words most important here. So fair, unbiased, random toss. Random task. These type of experiments are random experiments. These type of experiments are random experiments. It is a naturally like that. It is a nature naturally called naturally. Don't we interrupt. Don't we force. Okay, we can't use our knowledge. Only is a freely, naturally. So that is a random experiment. That is a random experiment. So children here. So the experimental or empirical probability. So using previous experiments, we try to give that formula of probability. We try to give the formula of probability. So here, listen, the experimental or empirical probability P of E. Here, P means probability. Here, E means event. E means event. So P of E of an event is, okay. Children, please note down this formula. P of E is equal, probability of an event is equal, number of trials in which the event happened, total number of trials. In previous example, 24,000 times he tossed the coin. How many times had? How many times? Nearly 12,000. So here, number of trials in which event happened, 12,000 by 24,000. Have understood, children? Here, P of probability of events. Another example we take, if we toss the coin, getting a head. So the probability of getting a head, for example, the how many number of times in which event happened? Only one. Total outcomes, the favorable outcomes is here 1 and total outcomes 2. So this type. So here the probability, the formula of probability is, write down children, the formula of probability P of E is equal number of trials in which the event happened, number of trials, number of heads getting in that situation, number of tiles, number of heads getting, number of tiles or number of heads getting. So here total number of trials. Already we give the definition of trial. What's a trial? If we toss the coin, is a trial. How many times? 1,000 times. Whatever it may be. 1,000, 24,000, 5,000 is the total number of trials in denominator. So, write down children here, P of E, probability of an event E is equal number of trials in which the event happened by total number of trials. So, we must remember this formula. This formula can use throughout the chapter. So it is very, very important formula. Children, rewind it. And now some problems are here. Do this, children. Outcomes of which of the following experiments are equally likely? Already we give the equally likely, the word. Already we learned equally likely, the word equally likely. Equally likely, the word. Equal like means they're equal. It would be, must be equal. You certain have same chances. Equally like means same chances. So getting a digit 1, 2, 3, 4, 5 or 6 when a die is rolled. Getting a digit here, how many digits are there? 6 digits. 6 digits. A die has how many digits? 6 digits. In a die, some dots are there. In some dies 1, 2, 3, whatever it may be. So getting a digit. if we roll the die, on the top, we may get 1 or 2 or 3, 4, 5 or 6. Tell me what is the, is it equally likely? So you imagine, children, you imagine if we roll the die, what on the top, what we get here? Whatever, 1, 2, whatever it may be, there are same chances, all equal chances. All are equal chances. So it is equally likely. Can you understand, children? Getting a digit when we roll the die is equally likely. Why? Because all numbers are getting equal chances. All numbers getting equal chances. So it is equally likely experiment. And then number 2, selecting a different color ball from a bag of 5 red balls. 5 red balls, 4 blue balls, and 1 black ball. Here, in a bag. How many red balls are there? 5 red balls. How many blue balls? 4 blue balls, and 1 black. We may pick out 1 ball. Is it equally likely? Imagine. Tell me, is it equally likely? Yes, children, it is not equally likely. Why? Because here chances, red ball chances is very high. Chances high than blue or black. Red ball chances is high, more than 4 blue balls, black balls. So it is not equally likely. Okay. And then winning a game of carom. Tell me, children, what here equally likely? So both have same chances. They will win the match. Okay. Winning a game of a carom is equally likely because chances is 50-50. Chances is 50-50, equally likely. Okay. Next, units place of 2-digit number selected may be 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. Units place of 2-digit number. We recall the 2-digit numbers. What are they? Which are starts from 10, 11, 12, 13, 14, 15, up to 99. 99. In the number, unit place is what here? 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So these words are repeated only. Another word is not repeated. Only these numbers, these digits are repeated. Only imagine. Already you note down 10, 11, 12, 13, 14, 15, 16, 17, 18, up to 99. And observe the units place is what numbers are there. Whether it is 0 or 1 or 2 or 3, 4, 5, 6, 7 or 8 or 9 only. No other digit is there. So here, so it is equally likely. Equally likely experiment. Next, 5, selecting a different color ball from a bag, 10 red balls, 10 blue balls, and 10 black balls. In a bag, 10 red balls are there, 10 blue balls are there, 10 black balls. We randomly pick up a ball. So it is equally or not? So see example here, 2 and 5. So here is not, second one is not equally, but here all are have equal chances. 10 red balls, 10 blue balls, 10 black balls. So it is equally like. And the 6th one, raining on the particular day of July. For example, July month raining. So it may be rain or March. So it is not equally likely. Why? Because in that particular day, is raining or March. It's not depends upon me. It depends upon nature. So it is not equally likely. Sixth one is not equally likely. Next, here are the outcomes of every experiment equally likely? You children, tell me children, are the outcomes of every experiment equally likely? All are equally likely? No, some were equally likely, some were not. Okay, right. And another, give examples of 5 experiments that have equally likely outcomes and 5 more examples do not have equally likely outcomes. This is for you children, this is for you children. So write down situations or 5 situations, equal likely and some not equally likely. Okay, you must note this one, 5 examples, 5 examples that those are equally likely or some not equally likely. This is for you children. So please do this problem. Okay, so five examples of equally likely, 5 examples of not equally likely. Already we may learn. Okay, right. Next activity is there children. Take a coin, toss it 50 times, 100 times, 150 times, and count the number of times a head and a tail come up separately. Record your observation in the following. Not only 50, 100, 150, you may toss 200, 250 like this. So this is activity you must do these children. So number of experiment. Take a coin children. You may toss how many times? 50 times. Number of heads are what? For example, we toss 50 times, number of examples, so 25, 26, whatever, 25. Probability head. Probability means chances. Number of heads are getting heads are 25, for example, by 50 or 24 by 50. Okay, number of tails. If we got 20, 24 here, 26 here, so 26. So probability of tail is 26 by 50 like that. So we may toss 100 times. The getting of heads, write down here, 45 or 46, whatever it may be, 49. So probability that 49 by 100, 49 by 100, write down in this box. And here number of tails, remaining number of tails. Probability is getting chances are there and total trials. Trials happen on the numeric and total chances is here. So here some order for 54 by 100 like that. And you may toss 150 times. You may toss 150 times. Getting heads how many times? You count it. Every time you do this activity and you must find probability of head and probability of tail. So observe. What is probability of head is, what is probability of tail? You must observe and mind it. Okay, children. So this is, so number of experts. This is one of the activity you must do. Today you must do this one and note what number of heads. Note down here number of heads and probability and tails and probability. Okay, do this activity, children. All of you do this activity. And probability and modeling. Probability modeling. Children, here the requirement of repeating an experiment has some limitations. So as it may be very expensive or unfeasible in many situations. Of course, it worked well in experiments of tossing the coin, throwing a dice. But how about repeating the experiment of launching satellite in order to compute the empirical probability of its failure during launching? Here, it is possible to toss a coin 20 times, 150 times. But in some situations, in some other experiments, like launching of satellites, we compute the empirical probability is very difficult. In toss situation, we may do so many times, but launching of satellite and computing empirical probability is more difficult. So the failure also. And in some other situations, repetition of phenomena of an earthquake to compute the empirical probability of a multi-stored building getting destroyed and earthquakes. For finding these probability, we calculate models of behavior and use them to estimate behavior and likely outcomes. So these situations, we can't do experimental probability. It is not possible. Because it's very difficult in toss and roll the dice. The situations are lively, but in some situations, these situations, launching satellites and some earthquake situations for finding empirical or experiment probability, such models are complex and validated by predictions and outcomes. So here we predict the outcome. Forecast of weather, forecast of weather, result of an election, and population, demography, earthquakes, crop production, etc. are based on such models and their predictions. So we may predict the outcome in among these situations. Forecast weather, result of election, before election, before election, exit polls are there. Some exit polls are there. So in that situations, only we take predictions, all based on such models and their predictions. We predict the outcome in these situations. So these type of prediction. So the critical probability of event T, that is experimental probability, this is theoretical probability. So two experimental probability here, theoretical probability. Theoretical probability are called classical probability of an event T, written by P of T is defined as P of T is equal to number of outcomes favorable to T, number of all possible outcomes of experiment. So here two types of problems are there. The first one is experimental or empirical probability. The next one is theoretical or classical probability. Because in that first situation, we do the experiment, but in second situation, it is very difficult to do that chances. That's why we take predict the outcome. So using that here, we take probability of T, theoretical probability. So generally we take theoretical probability as a probability. Generally we take theoretical probability as a normal probability. So P of T is equal to number of outcomes favorable T by number of all possible outcomes of experiment. So that is also formula equal to this one. So in these two situations, experimental probability and theoretical probability. Experimental probability, theoretical probability. So where we assume that the outcome of experimental are equally likely, we usually simply refer to theoretical probability as probability. So we may take a theoretical probability as a probability. What is the formula of theoretical probability? Probability of theoretical probability is equal to number of outcomes favorable to T, here favorable, number of all possible outcomes of the experiment. So it's a very most important formula. Most important. The P of T is equal to number of outcomes favorability. When we toss 4040 times, heads are 2000. 2000 favorable means 2000 and possible 4000. So this is the theoretical probability. So we must understood what is experimental probability and what is a theoretical probability. The difference is slightly different. Slightly difference is there. So here probability formula is same. So we may take theoretical probability. Generally we take theoretical probability as a probability. Have understood, children? The probability is theoretical probability, we take general probability. So P of T is equal to number of outcomes favorable to T. So number of outcomes favorable. Here we take E, number of outcomes favorable to E by total number of possible outcomes, number of possible outcomes. So children, this is a very, very important formula. So please practice this. Already using this formula, we may do so many exercises, total exercise based on this formula, children. So you must write down these exercises and also please learn about this. Sir, hello.
Sir, Purushottam sir, 9:55 అయిపోయింది. 10 o'clock మనకి TSAT classes ఉంది sir.
Okay, children. So here, I will control. So today we learned only experimental probability and classical probability. So you read and practice this well, and you must understood, and we will continue tomorrow. Thank you, sir.
Thank you very much, Purushottam sir.
Sir.
So that is the end of the today's class, which is already introduced the basic concepts, how the probability is defined, and what are the main things you have to observe while you are finding the probability, and what is the experimental probability and what is the theoretical probability. The difference between those two is given, and the terminology that is used to find the probability in the given 10th class stipulated part. What is equally likely, more likely, all the terminology is introduced to the students today. Children, please go through the terminology and you define and understood the basic concept and the detailed information about those words. So once you got the concept and you practice that one, that will be more useful for you in the next upcoming classes, which will be taught by our Purushottam sir. See you tomorrow at 9 o'clock, and that is the end of the today's class. I am Muva Prasad signing out from the DCEB Suryapeta. Thank you for the technical team who supported for the live telecast classes from the past 5 months. Thank you very much.